Hey everybody, this is Larry, this is me going Q3 of the weekly contest 355, maximum number of groups with increasing length. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one Josh and a couple of people tells me that there's a non-binary search solution, but I did it with binary search, so I'm going to explain this one. Maybe we'll explain it up like an upsell at some point, but not in this video. I just want to kind of, get it out there. But basically the idea I had was just binary search, right? And what I mean by that, basically I just target like, hey, what's the answer? Can we do it with X groups? And if you can do it with X groups, then, I'm not going. This is a hard problem, hard rated difficulty, so I'm not going to go over the nuances of binary search. The prerequisite for this problem, for me, for this video, will be that you already know binary search, because binary search by itself will be a medium, and you can practice your binary search portion on easier problems, and then maybe come back to this later. And the idea behind the idea that I have is that. So first of all, the case that I had initially was 222, meaning that you have basically, if you want to visualize it out, you have 2 zeros, 2 ones, and 2 twos, and then here you can actually make 3 things, right? So you have 0, 1, 2, you have 0, 1, and then a 2, right? So you can make 3 groups. So that's basically the idea. So, and that was the driving case, even though I actually end up having a wrong answer, but it just apparently had a silly typo. But yeah. But the idea that I had was that, okay, let's say we, in a greedy way, line up all the numbers as best as we can, right? So maybe, maybe there's more ones and twos and so forth. And the idea is always going to be that, and maybe there's 3 and 4 because you need more numbers for it anyway. But the actual numbers don't really matter. They're fungible. You can exchange them. But basically the idea that I had was so the initial greedy idea is that you always want to take the most, like the maximum numbers, right? For example, we have 5 things, so you always want to take out a 5, and then maybe a 2, and then 3, and then or a 0, and then a 3, and a 4 for the top layer. And then now you have this, so then you take 0, 1, 2, and maybe 3, right? And then now you take 1, and then you take 0, and something like this, right? Yeah, it doesn't. I mean, and then that's well, you only need 2, but yeah. So you get the idea. Maybe I'm off by 1 here, but whatever, right? So that was just. So the idea that I had was that, you binary search on the end, so that you start with constructing the biggest, so then you can kind of do it that way. And the thing that I don't know how to explain this very well, because I think this is a hard problem. Because in fact, a lot of people. On the top people spend more time on Q3 than Q4, maybe, right? So yeah, and the idea that I had visually is that so instead of kind of visualizing it like this, I kind of visualize it vertically, right? So I have 0, I have 1. And then I have 2, and then I have 3 and 4. Maybe you could, just for fun or whatever, right? So then the idea here is that when I do a 5, I always take it from the top, right? So if I try to do a 5, I take it from the top, and then next I take it from a 4 and dot, right? So that maybe, is visually makes sense. But then the idea is what happens if you have too many numbers, right? And that's a good thing. But here is that, okay, first you take a 5, and now you only take 4. So then now you have 1 extra number here. And because the next number, you know that they're only 3, and 3 is less than 4. And why does that matter? Why that matters is that because we have an extra number, and we don't even care about which one it is, but the way that I would think about it is maybe like a rotating thing, is that if we have any extra number, then by definition, you want to use a number that you used in the last round. So then it can be any other number. So, maybe we bring over the 4, right? And then now there's no numbers left over. But let's say, we already have a 3 and we have a number. We have 2 numbers left over from here. So that means that we can carry the 4 and the 0 here. And then now we have 3 numbers left over. We have 2 numbers left over. Ooh, what did I click? And then you can kind of add it, in each way. And then you still have 2 numbers left over. And then basically you kind of carry over the choices that you have, knowing that on the next one, oh, this is a 1. But yeah, you get the idea. And that's basically my thought process about binary searching on this. Oops. Again, I'm not going to go over binary search in this video because I want to focus on the meat, and the rest of it is kind of hard. So yeah, but the idea here is that, okay, so I keep I basically do a prefix sum up to n, right? Meaning if something shows up n plus 1 times, we just do it n, because, well, you can't go more than n rounds anyway, because you don't, because of Pigeonhole, you don't have enough numbers to have that many rounds. So we max it we capped it by n, and then we just kind of subtract it all the way down, so that we have, for each level, we have the number. So then at the end of this, prefix sub I is equal to the number of unique numbers that has count of I, right? Or count equal to I, right? So that means that prefix of 1 means that how many numbers have 1 appearance, how many numbers have 2 appearance, and so forth. And here's my good function, is that, okay, so then now we start we start at, depending on how you want to say it, like I said, we try to fill out the top row, which is, the target. So we fill out the target row, we add the number of numbers that are available to us. These are kind of the leftovers, if you will, because we kind of pass it on. Yeah. Hopefully this is right. Otherwise it'll be really sad. But yeah, but otherwise, yeah, if we don't have enough numbers, we return false. Otherwise, we remove that row, almost like a Tetris file. You just swap off the top. And then this gets smaller and smaller. We have leftovers that we can really use. But yeah, that's pretty much all I have for this one. This function is linear. So yeah, this is going to be n log n, because this is capped by log n in binary search. That's all I have for this one. Let me know what you think. Let me know if the visualization was good enough. But basically the idea is just, I think the way that I drew it is the way that I thought about it, with respect to kind of go down the list and then passing the leftovers that we don't use. But yeah, that's all I have. You can watch me solve it live in the contest now. Branded 2111. Okay. That was a little bit sloppy. Increasing length. Each number I is used no more than each. Oh, I see. So 0 once, 1 twice. Huh, we have 2 hearts today. Huh? So take my time a little bit. And it's big. Each group must consist of distinct numbers, okay? Each group must have a length strictly greater than the previous group. Huh. Okay, I mean... well, n is going to be the most, so okay. And we can, the numbers don't matter, so we can sort. Don't always take the biggest number. Because then, for example, you could have 2, 2, 2, and then you just take 1, 1, 1, 1, 1, 1, and that would be good. So you can't just like greedy suffix sum or whatever. Naive is n square. This feels very similar, but I can't really get it. Okay, so let's say you have to right? I mean, it's gonna keep on getting the max, but I don't know quite how to do it. Instead of binary search. What do we do it back? If we binary search, can we do it backwards? Do 3, so 1, and then do the. By definition, can I do a binary search? Is that chorus? I mean, yes, but can you do it fast enough with binary search? Wow, people are not getting this one, so. Huh. I don't know this one. You can that is 2. And log n square, it's a little bit slow. How do I binary search? Can I greedy with binary search? Not the way that I'm doing it, that's going to be n squared. Let's see real quick. No one got that one yet either, so. Huh. I feel like binary search is probably the way to go, but I can't think of how to do it correctly. Because then now you could do it from the top. But Still have the thing where you go do the prefix thing. You have 222. What does that mean? You got 222. One left over, right? Is that right? I think that's roughly right, maybe, but I don't know that I can prove it. One person got it. Wow, congrats to that person. Okay, and then what am I doing? Yeah, I mean, it doesn't even matter, right? So this has to be named this and right, and then basically, yeah. If this is good, then we try something bigger. So left is equal to mid. And then the hard part, of course. I have to do some weird thing for this. Should be target maybe. So this is less than target. Otherwise, this is good. Maybe? I don't know if this is true, to be honest. That's not right. Why is that not right? No, but I'm very thankful that I better get it before. I better get it wrong here then, you know. So 0, 3, 0 is wrong. Oh, I see. This is just weird the way that I wrote it. But still not right. Okay, so we have to, this is the prefix with one thing, that's 3. And I think this don't go to -1. But is this inclusive? Maybe that's why. Nope. Maybe that's not the issue. Good is 3 is false, so I have to fix that. Why is that false? I think I did this wrong. This isn't quite right. Can I have 3 things? What am I thinking of? I think this is actually, yeah, maybe that. But is it right? So it is 3, 2, and 1. Okay, fine. What is this prefix? I think I, oh no, I see, yeah. So the 2 things, the 2 things with 2, 3 things with 1, and 1 things with 3. I mean, can't tell, I cannot walk through my logic. I think I'm just lucky with this input. I don't even know how to debug it or not work it through. Okay, so we have 3 things. That's good. Okay, so we satisfy the 3, and then we try to satisfy the 2. We have 2 things with 2. I think I'm just lucky on this one. I don't think this is quite right. 2 things with 2, what does that mean? 2 things with 2, what does that mean? Two things with 2 means that this feels weird. Means that there's at least 2 distinct things. Okay, maybe this is right. I don't know. I don't think so though. But I hopefully this will give me a wrong answer to kind of debug it. Yeah, okay. So I don't know how to do this one, to be honest. Only 3 people got it is ridiculous. How more people got this one? 6 people got it, so maybe I had to skip ahead a little bit. 1771. So what does that mean? 4, 4 to 2. So 4 things has 1 thing, only 2, right? So we search for 4, then 3, right? So why is this good? Did I mess this up? So 4 is true. Why? Okay, so and then we minus 4 things, and then now we do 3 things, but 3 things we should already be at 2, right? Did I mess this something up? Just so that I can do this. Okay, 1, 2, 2. Oh, this I is wrong. I wanted, I changed the other thing and I forgot to change this one. Target one plus 1. Okay. I see. Silly mistake maybe. I don't know if this is right though, but it's at least a silly mistake. I mean, it's more right than before. But now this thing is wrong again, so yeah, it's good. At least it's let's see. At least the server seems to be running pretty okay, knock on wood. Okay, so the target is 2. Okay, let's see, the target is 3. So first one, 3. Target is 3, you do 1, and then you do 3, right? Okay, and 2. Oh, this is wrong too. Because now, wow, what am I doing? Is target minus I plus 1. What am I doing? Wow, I'm really not thinking it through today, right? Like, I feel like my logic is, I don't know, my logic is right, but definitely my coding is very wrong. All right, YOLO, let's give it a submit. Huh? So I had the right idea apparently, but I just kind of implemented very stupidly. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. A pretty hard one, right? And on this forum. Yeah, let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.